Hello viewers, welcome to my maths class. If you are new to this channel, please, I will encourage you to subscribe to my channel because this channel is purposely used for teaching mathematics topics across various levels of education, like primary school, secondary school, as well as A-level mathematics topics. So if you are new to the channel, please kindly subscribe to my channel so that any mathematics video I'll post, you can receive it. Now, today we are looking at laws of indices. Laws of indices with examples. Laws of indices with examples that will help you to understand the laws better. Yeah, but before we take the laws one after the other, let's have a flashback on the general meaning of indices. Now, we know that numbers written in this form, let's say 2 power 4, 3 power 8, numbers written in this form are what we term as the indices numbers or the index numbers. Good. Now, whenever a number is written in this form, we have the one up there and then the one down there. Let's even look at the first one. Now, these two numbers, the one up there, usually we call it power or index or exponent. And the number down there, we call it base. So whenever a number is written in this form, the top one is called, you can call any of these index, exponent, power, and the down one is termed as base. Good. Now, because of the laws that you are going to consider, we need to have these terms in mind because it will come across as we move along the laws of indices. Now, let's take the first law. Let's say law 1. Now, law 1 says that A power m times A power n, that is, if you have two index numbers multiplying each other with a common or same base, you realize that we have base A here, we have base A there. Then the law says that we can take one of the base A and then we add the powers as m plus n. M plus n. That's the first law, law 1. Two index numbers multiplying each other with a common base. Take one of the base and then we add the powers. Example, we can have 2 power 2 times 2 power 3. And according to the law, this one should be equal to taking one of the common base, base 2, and then add the powers. 2 plus 3, that will give us 2 plus 3, will give us 2 power 5, right? Then 2 raised to the power 5 is going to give us what number? 2 multiplying itself 5 times. And that's going to give us 32, right? That is 2 times 2 times 2 times 2 times 2. So 2 times 2 give us 4, times 2 will give us 8, times 2 will give us 16, times 2 will give us 32. So 2 power 5 means 2 multiplying itself 5 times. So that is the first law. Now let's look at the second law, that is law 2. Now for law 2 says that if I have a raised to the power m, no, the first one was multiplication. This time around, we are looking at division. A power m divided by a power n. A power m divided by a power n. Same way, we have same bases here, base A, base A. So if two index numbers are dividing each other with a common or same base, the law says that we can take one of the common base A, and what do you do to the powers? We subtract the powers as m minus n. So for addition, take one base, add powers. For subtraction, we take one base, one of the common base, and then we subtract powers. Example, 3 power 5 divided by 3 power 3. This is equal to 3 raised to the power 5 minus, we take one of the common base because the base are the same. So we take one common base, 3, we subtract powers as 5 minus 3, and this will give us 3 raised to the power 2. And 3 raised to the power 2 means 3 times 3, giving us 9. Good. Now, for the division of index numbers with a common base, sometimes you can have the division symbol like this. Sometimes you can have the bar. Yeah, have it in mind. A power m divided by a power n is the same as this. A power m divided by. So you can either have the division symbol like this or you can have the bar. It's the same thing. So let's have that in mind. Now let's move on to the next law. That will be law 2, law 3. Now, the law 3 says that if I have an index number, let's say a raised to the power m, raised to another power, an index number raised to another power, this can be written as, you multiply the two powers together, so a raised to the power m times n will give us mn. Example, 5 raised to the power 2 raised to the power 3, r raised to the power 2. So you can have this situation. And this index number raised to another power. And this is equal to the base 2, that you multiply the two powers together. That is 3 times 2 give us 6. And this is equal to 2 multiplying itself 6 times. 2 times 2 times 2 times 2 times 2 times 2 is going to give us, now 2 multiplying itself 5 times give us 32 times another 2. That will give us 64. Good. Now let's look at the law 4, the fourth law. Now, the fourth law says that if I have a fraction, let's say a on b, all raised to a common power like this, a fraction with a common power, then this one is equal to the power affect both the numerator and the denominator. Both the numerator and the denominator. So this one can be written as a raised to this power, b raised to that power. So a power n over b power n. Example of this, we can have 2 on 3 all raised to the power 2. 2 on 3 all raised to the power 2 is equal to these 2 raised to the power, that is 2 raised to the power 2 over 3 raised to this power, 3 power 2, and this is equal to 2 power 2. 2 times 2 will give us 4 divided by 3 raised to the power 2, that is 9. So we have 4 on 9 for that one. Now let's look at law 5. Law 5. Now for law 5, we are going to look at a negative power. A negative power. So let's say we have a raised to the power minus n. Now when you have, now this law is going to change the negative power to positive. This law will change the negative power to positive. And this is necessary because whenever you have a negative power, it becomes difficult to deal with it. So you must change the negative power to positive before you can deal with that positive power. So a raised to the power minus n, to change the negative power to positive, the law says that you just take the reciprocal of the number or the base. Yeah, and as soon as you take the reciprocal of this number, the power will change to positive. So this one can be written as a over 1 over a raised to the power positive n. Positive n. So whenever you have a negative power, just take the reciprocal of that number and then the negative power will change into positive. Good. For example, if I have 3 raised to the power minus 2, as it stands, 3 raised to the power minus 2, if you are asked to give a direct answer, it will be difficult because of the negative power. So we apply this law to change the negative power to positive. As take the reciprocal of this term, 1 on, and as soon as you take the reciprocal of that term, the negative power will not change the positive. So we have 1 on 3 raised to the power 2. And because we have a positive power here, we can now find the value of 3 power 2. And this is going to give us 1 on 3 power 2 is 9. We look at law 6. Now, for law 6, it's also a fraction with a negative power. Unlike this one, we have a fraction with a positive power. But when you have a fraction with a negative power, how do you deal with it? So let's say I have a on b all raised to the power minus n. A fraction with a negative power. How do you deal with it? The negative power must be changed to positive power before we can deal with it. So how do you change the negative power to positive when you have a fraction with a negative power? Now this one is very simple. Just interchange denominator and then the denominator, interchange their positions. So the denominator will go up, becomes a numerator. The numerator comes down to become a denominator. Through that process, the negative power will not change into positive power. So just interchange numerator and the denominator, and the power becomes positive. See, it's very easy and simple. So example of that law, let's have an example of that law here. Example, let's say I have 4 on 5, all raised to the power minus 2. In order to be able to calculate this expression with ease, we must change the negative power into positive power. So this one, to do that, just interchange both the numerator and then the denominator, and the negative power becomes positive. So denominator goes up, numerator comes down, and the power now becomes positive. And this is equal to, once we have a positive power, we can now deal with this one. We are going to have 5 raised to the power 2. That will give us 25. On 4 raised to the power 2, that will give us 16. Then let's look at law 7. Now, for law 7, we are going to look at a fractional index. A fractional index. So let's say I have a raised to the power 1 on n. This time around, the power is a fraction. If you have a base with a fractional power, how do you deal with it? Law 7 is going to help us. Now, this a raised to the power 1 on n is going to give us, this is going to give us the nth, because the denominator is n, the denominator of the fractional power is n, is going to give us the nth root of the base. So this will give us the nth root of the base a. Nth root of the base a. For example, so a raised to the power 1 on n is equal to nth root of the base a. For example, let's say I have 2 raised to the power 1 on 4. 2 raised to the power 1 on 4, and this is equal to, the denominator is 4. The denominator of the fractional power is 4. So it becomes 4th root. 4th root of the base 2. 4th root of the base 2. I think this is not difficult at all. Good. Let's look at law 7, law 8. Now, law 8 is also another fractional power. This time around, the numerator of the fraction is not 1. It's a number other than 1. So let's say I have a raised to the power m on n. This can be written as the nth root. The nth root, don't forget that this one is the same as a raised to the power 1 on n raised to the power m. This one is the same as this, because the power here, multiplying this power, the power m will multiply the numerator 1, and that will give us a raised to the power m on 1. So this and that are the same thing. Good. This and that are the same. So once the fractional power has a denominator of n, this will give us nth root of the base a all raised to the power the numerator. So the numerator here becomes the power of the whole nth root. So if I have a raised to the power m on n, it can be written as this one. Good. And the explanation is, why is this? is because of the fact that this one can be written as this. Good. So a raised to the power 1 over n will give us the nth root of a, all raised to the power m. So that's what we have over there. For example, I can have 3 on 4 raised to the power, I can have 3, let me say 5, yeah. 5 raised to the power 3 on 4. And this one, according to the law, can be written as 4th root of 5, all raised to the power, which is the numerator of the fractional index here, fractional power. So raised to the power 3. I'm sure this is not difficult to understand at all. Let's look at our 9th law, law 9. Now, for law 9, we are going to have, it's also very simple. Law 9 is about a zero power. So a raised to the power 0 is equal to, now the a being a base here stands for anything. So anything raised to the power 0, the answer is always 1. Anything raised to the power 0, the answer is always 1. So for example, 100 raised to the power 0, the answer is 1. 56 raised to the power 0, the answer is 1. 8 raised to the power 0, the answer is 1. So anything or any number raised to the power 0, the answer will always give you 1. Good. I hope these laws are useful and also easy to understand.